We are now going to review design concepts for the vSphere virtual network. We've covered much of this material in detail earlier in my course on virtual networking basics in vSphere. We're going to go through these items. We are going to look at NIC teaming in some detail, but again, we will sketch everything out and look at the options, the pros and cons. We look at load balancing possibilities that exist, and some of the pros and cons, and some details around how you can actually understand which link is being used. That goes hand in hand with link aggregation groups. We look at some of the capabilities that exist in vSphere 6 around link aggregation groups. We'll also look at IP storage. Because IP storage is much more prevalent, and there's less of fiber channels. So we need to understand what we need to do for iSCSI and for NFS, and we'll go into that in some detail as well. We'll also look at various options if you have servers with fewer NICs, physical NICs available, versus servers with more virtual NICs available. Not that long ago, servers used to have 6 to 8 physical NICs. Each of them were 1 gig. And then when blade servers came to the fore, and that is usually still the case on the smaller blades, the half-width blades, for example, that Cisco Unified Computing System has. You have a limited number of uplinks, so you go between 2 and 4 usually, but then they are 10 gig. So different ways of virtually splitting them up would be one way, or to use the full physical bandwidth and then use some load balancing from the ESXi side would also work. So we'll explore some of these. We're going to use the whiteboard quite a bit. So let's jump right into NIC teaming, and then we will cover load balancing, link aggregation groups, and IP storage. So we are now at the whiteboard, and we are going to look at NIC teaming and some of the considerations in design. So I'm going to draw a virtual switch here, and we are going to assume that there are 4 physical NICs connected to it. So VM NIC 0, 1, 2, and 3. And let's assume there is a port group here. Let's just call it PG1. Okay, so one port group, and we have 4 physical NICs available. Now, for this port group, as you know, you can define, for this port group, you can define which one of these physical NICs will be used for that. So one option you could have is that this physical group, and I'm drawing a logical diagram here, so you have PG1 is actually going to use VM NIC 0, and it's going to use VM NIC 1. Now, a couple of possibilities exist there as well, and they go like this. So for this port group, in that virtual switch, you have said that it will use VM NIC 0 and 1, and now we need to determine what kind of NIC teaming we want. So some of the options you have are like this, right? VM NIC 0, we'll just make a table here if we can. VM NIC 1. So option 1 could be that VNIC 0 is active, and VNIC 1 is also active. That's one option. So in this case, any traffic coming in from a virtual machine, for example, in this case, a VM1 coming in, will use one of these VM NICs depending on the pinning that is determined by the load balancing that has been defined. So if you've said route based on your port ID, there will be a hashing that will be done, and basically one of these VM NICs will be selected. If you have a different virtual machine coming in here and other virtual machines up to VMN, then you have the same situation. Based on their port ID, there will be a hashing that will be done based on the fact that there are 2 active NICs available, and the traffic will be load shared essentially and pinned to either one of these either one of these NICs, and so you have active basically as your as the way that the VM NICs are actually operating. The other way you could do this is by saying, okay, VM NIC is active. So now we look at option 2. It says VM NIC 0 is active and VM NIC 1 is standby. Well, in that case, obviously we are going to be using only one NIC, right? So you would have a situation where you said VM NIC 0 is active, and actually all traffic is going to be using this VM NIC, and nothing is going to be on VM NIC 1 for this port group. Not really a good situation in terms of using all the capability that you have. So what people normally do is that if you have another port group, for example, on this switch, so I define another port group here, PG2, and then we kind of try and sketch out in the same way that the usage of that. So for port group 2, you could still say, yep, we're going to use VM NIC 0 and VM NIC 1 as well, just like in this case, right? And we have traffic coming in there as well. So virtual machines are here as well. So we have multiple virtual machines here. What you could actually do is, and let me use a color to split the diagrams here apart a little bit. Okay. So what you can do for port group 2 is we can draw a similar table here, right? So VM NIC 0. One of the options you can have is to actually make it standby for that port group, and you can make VM NIC active. Now this is a pretty good solution, and this design pattern is actually used quite a bit. So you can see what we're doing here. We're saying that for port group 1, we are going to, in this option 2 here, we are going to make this active. So this is active, all traffic is flowing. The other one is standby and will actually become operational if the primary VM NIC actually fails, if the active VM NIC fails in this, because it's on standby. But at the same time, we are not losing the capability of bandwidth that is available with VM NIC 1, because for a different port group, we have given the opposite, so to speak, kind of a NIC taming. So we've said VM NIC 0 will be on standby. So VM NIC 0 will stand by for this one, but the VM NIC 1, which is not being used here by PG1 because it is on standby, will actually be made active. So you have now taken care of making sure that you are using the full bandwidth that is available to you, because now you're using both VM NICs 0 and 1 in different port groups. But at the same time, you're also ensuring that you have some resiliency, because if one of the NIC fails, then you will be able to transfer over to a different NIC. Now, of course, the issue here is that if VM NIC 1 fails here, the traffic of PG2 will also come in here, right? Will also be utilizing. So PG2 will also start utilizing this. So both PG1 and PG2 will then start utilizing the remaining active VM NIC that is in that team. Now that may or may not be a good thing, because it is non-deterministic, in the sense that traffic that was originally flowing across two links is now all flowing through one link, and you might have congestion. And this is where you may actually consider different approaches here, in terms of you can use other options in network IO control, for example, to control your traffic of the various VMs, so that they get at least some kind of minimum bandwidth. But certainly in this case, you have some congestion problems more likely if there is a tremendous amount of traffic flowing on port group 1 and port group 2. So it's a good idea, but there are certain issues with it, but again works quite well if you have managed your traffic association to port groups appropriately. Let's go to a different kind of a model. So I'm going to clear this screen, and let's now look at a physical server. So the physical server is going to be a server where we have some people will say this is very old-fashioned, but I think we are not going to worry too much about that, because after all we are just looking at design concepts here. VMNIC 0 through VMNIC 5. Now if you consider the types of traffic coming onto this virtual switch, there are some interesting ways you can actually split it up. So you have system traffic, and I know there are many more different kinds of system traffic than I'm going to write down here, especially in ESXi. But again, we are looking at concepts here. There's management traffic primarily. There's vMotion traffic, and you have IP storage traffic. And of course, in the VMware NSX world, there is VXLAN traffic. Let's see if we can think our way through this as well. So management traffic usually is important and will not take up too much bandwidth unless you are running things like fault tolerance, but then you have capability of doing different things with that as well, or if you have a separate vMotion network setup, then you're in good shape, because that will not use the management ports. So if you have a situation like this, you could basically assign the various traffic in this manner, and obviously there are many different options here, so I'm going to just define one option. Okay, I can say that what I'm going to do is I'm going to bundle these. Let me write down the numbers first. So that's 0, 1, 2, 3, 4. These are your physical links, right? I could say I'm going to bundle these into a link aggregation group. Let's just call it lag1. Okay, I will say that I am going to actually treat VMNIC 0 and VMNIC 1 as a NIC team, and I will assign active or standby as is required for whatever kind of traffic that I need to have here. And then I will say that I'm going to treat 2 and 3 independently, but that's never a good idea. You always want some kind of a standby. So again, the recommendation is you look at it as maybe yet another NIC team. So maybe you want to, it's a NIC team 0, and of course we don't really name this in ESXi, but for our discussion purposes this would probably work. So we now have 3 groupings of our 6 physical NICs. Okay, now IP storage, it's a good idea to have it on a separate network, right? And that's I've drawn this in like a purple. So I might say I want to assign IP storage to this lag bundle, right? So which means that upstream you need VPCs or MLAGs. Okay, now this is usually a good idea, because even if these are 1 gig ports, assume they are 1 gig, you have a decent amount of traffic that's traversing this. But in the modern world you would probably have 10 gig. So a 20 gig capability for bandwidth is usually plenty for IP storage. And of course the link aggregation group gives you resiliency as well, because if one link fails, you still have a tremendous amount of storage traffic that can be sent through 10 gig. I read somewhere, don't quote me, but I read somewhere that usually people don't see more than 3 to 4 gigabits per second running on 8 gig fiber channel, I guess because of some overhead and so on. So I would not anticipate even on a highly loaded system that you will ever overload 10 gig, at least in my experience so far. So this is usually a very safe and very good design concept to actually work with. Let's look at management now. I will use a different color for management, and what we can say is that for management, this is active and this one is standby. So you have resiliency there as well. If the first NIC goes down, management traffic will actually still flow. Now, let's look at vMotion. I know that there are people that will say that they have a huge amount of vMotion traffic, and perhaps they have. If that is the case, then your vMotion traffic could actually be given its own NIC theme. And if they are 1 gig or 10 gig, in case you have the availability of 10 gig adapters on your host, certainly these things are possible. So what you could do is you can say vMotion is going to use this as active, and will actually use this as a standby. Okay, and then you can have your VXLAN specific LAN work in the opposite way. So see if I can find yet another color here. For the VXLAN traffic, yeah, it looks a little bit different. I can say my VXLAN traffic, I'm going to have this on 2 will be standby, so I used a different color, and the other one would be active. So I would not be sharing the physical NIC in under normal circumstances, but I would be sharing the NIC theme, and I would have resiliency for that as well. And basically, I'm getting a 10 gig of traffic out on my VXLANs for say an NSX implementation. So this is one way of doing it, and of course, you can see that there are many different combinations possible. If you have many physical NICs available. Now, usually that's not the case nowadays, right? You usually have 2 10 gig, or you have 4 10 gig, or you have 2 40 gig. It's usually something on these lines available on your servers. So you have to actually look at a different situation that we're going to look at now. So I'm going to clear this, and we're going to look at the situations from a host perspective, where you have say 2 10 gig adapters. So your physical switch is right here, and because one switch takes control of the physical adapters, in this case if you have only 2 of them, well, you probably have only one switch, VMNIC 0 and VMNIC 1, and each of them is 10 gig physical, right? Now, if you're running Cisco UCS, you obviously have the ability to take this bandwidth of 10 gig, and with Cisco UCS manager, define VNICs. These are obviously Cisco UCS VNICs. These are UCS VNICs, right? Define these. So you could split this out and say, out of the 10 gig, I have adapters that are basically going to use, I'm going to define maybe say 5 of them. I mean, you can define many more. But you could basically say that I'm going to define these of 2 gig. And again, the way it works is that with ETS, enhanced transmission selection, and with PFS, you are able to use the extra bandwidth, but you can say that I get a minimum bandwidth of 2 gigs. It's not a reservation. It's just the bare minimum at times of contention. So you can define these as 2 gig. Now to the ESXi host, right? These actually look like VMNICs. So no more is it's just 2 VMNICs. In this case, you're looking at VMNIC 0 through VMNIC. I had 5 of them, right? So I have 4, and this would then become VM NIC 5, 6, 7, 8, and 9 for a total of 10. So you'll have 0, 1, 2, 3. Now, these VM NICs are of course UCS virtual NICs, but from a ESXi perspective, sitting here, that's what the ESXi host sees. Now again, you have many options, and this is a really good way of actually, if you have access to UCS and CNAs converged converged network adapters, because they actually also pass fiber channel traffic over FCOE. So in any case, CNAs, right? If you have CNAs and you have the ability to partition them virtually using like a Cisco UCS or other utility, then you may want to consider some kind of a design that works on this design principle. Again, the specifics are hard to do unless you have a really good knowledge of the customer requirement here and the type of traffic that's going to kind of come in here. But again, conceptually speaking, from a design pattern perspective, this is one way of doing it. You could then have the ability to very fine grain in a very fine-grained manner actually allocate your system traffic and your virtual machine traffic in this case, because you actually have 10 VNX available, right? Each of 2 gig, so it gives you the full 20, and that's pretty good, right? The only downside here is that you cannot, I'm talking UCS here, in CS, cannot port channel these. So you cannot take these VNX, cannot port channel the VNX. Because these are virtual, and the uplink connections to the FIs, right? So you usually have your 2 FIs, FIA and FIB, control link only, and this is your upstream, right? So these connections here, okay, are basically 2 connections, right? Your 2 10 gig things, so they actually kind of go in like this. You cannot port channel those virtual NICs. You cannot say, okay, I'm going to take these and I'm going to port channel them, because this is a virtual connection basically happening here. Okay, so just keep that in mind in that situation, right? Which is where the NIC taming that we saw earlier with active standby, and maybe specifying, say, 4 of these VNICs into a NIC team is a very powerful way of actually doing it. And in fact, you now have the possibility, and well, while I'm thinking about this, let's just put that down on the whiteboard as well. When you assign a NIC taming in this manner, right, if you have 2 10 gig adapters available, and you have virtual NICs defined with say Cisco UCS, and each one of those virtual NICs is say 2 gig, right? So you have a total of 10 virtual NICs available to your ESXi host. The NIC theming option is actually very powerful. So even without doing port channel, even because you can actually do that, you can have groupings, right? You can say VM NIC 0 and VM NIC not 1. Let's go to the other adapter, which is which will have VM NIC 5 on it, right? Is a good way of actually NIC theming, and you can make them both active. So what happens in this case is traffic is flowing across both these links on an active basis, and even if one of those sides, say the A side, goes down, the B side is obviously going to take over because VMNIC is running on the other one. What you should not have done is to have VMNIC 0 and VMNIC 1 on that NIC theme, simply because on the physical adapter they're running on the same physical CNA, so you don't want to do that. Now, of course, you can expand this concept. You can say VMNIC 0, 1, and 5 and 6 are actually now as part of this NIC team, and that is a very cool way of doing it also, because now you're able to get the bandwidth as is available across 2 physical 10 gig NICs, and yet from your side you can treat it in a very granular basis from the VMware side. Okay, so this is yet another option that you have when you have a host with a limited number of high-speed NICs there. CNA, converged network adapters, usually. Now, of course, the same principles apply if you have instead of 2, you have, say, 4 by 10 gig. If you have 4 of these, your problems are obviously a little bit less. You have, again, some really interesting options. You may or may not decide, or you may or may not have a UCS consideration here. You may have different servers there and a different blade system. But if you have, say, UCS, suppose you have the C series servers, right? The Cisco C series servers, instead of the B series servers, which are blades that run inside the UCS chassis. These are standalone servers. You can use them with UCS if you like, and that's a very powerful way of doing it. Or no UCS, you can treat them as basically standard servers, right? So you have those options available. And in which case, of course, if you have 410 gig connections available, then it's very easy to expand this idea that we have developed on this whiteboard in terms of either splitting, non-splitting, and so on, because the concepts actually stay the same. It's just that you have more options available. Okay, so this is a really important part of what we have to do. So NIC teaming is very important. We're now going to switch gears and actually go over to the VMware side. And what we are going to do is draw this in a different color and look at basically our load balancing, or as some people like to say, it's actually not load balancing, it's load sharing, but there is one option available that actually does load balancing. So let's just briefly review those options. So if you recall, you can either route based on port ID, MAC address. There was basically this one, okay, on based on the IP hash. Load-based teaming is really very powerful, and we shall explore this in some detail here as well. Okay, and then you have a failover and things like that. So not really considering some of those. So the primary ones are port ID. IP hash was quite popular, but a lot of people use load-based teaming and then use port ID, and to keep things as much as possible deterministic, so you know what is happening at any given point in time in your design. All right, given this, we know that when you have a port ID, depending on the number of physical NICs available, the traffic is actually pinned to one of those NICs in those NIC teams. The load-based teaming we also have looked at before, where if for 30 seconds you have a greater than 75% utilization, then the traffic is actually moved to a different physical NIC. The nice thing about port load-based teaming is that there is no special configuration upstream, in the sense that you don't need any port channeling. That's really what that's about. Port channels, you don't really need that, and it is quite compatible because you don't need there are no port channels. It's very compatible. If you have a NIC team group, say you have 4 NICs here, VM NIC 0 through 4 in a NIC team, and you can maybe have them all as all active, NIC team active, all active. And you basically say that you're going to use the port ID mechanism, and for the port groups, so the port groups use this mechanism. You can spread your traffic pretty nicely across this. Now, you could use, and this is a pretty good idea actually, to use load-based teaming for IP storage. Right? What happens there is that because you have these adapters here, right? So we have, say, VMNIC 0, VMNIC VMNIC 4, and you're using a load-based LBT, load-based teaming. IP storage actually works very well with load-based teaming because it has been found that whenever one of those physical NICs is being used too much, the system just switches the traffic over to another VNIC. So at least coming out of the ESXi host, although you are switching traffic occasionally, when the bandwidth is very constrained on one given physical link, there's no special upstream configurations that are required. So you could simply say that your 0 and 1 VNICs are connected to, say, switch 1, and your 3 and 4 are connected to switch 2. Now, of course, if this was UCS and these are not real NICs, you would do it differently, but you get the idea. I mean, there's no lagging required here, and this would work in many situations, because if you're using data center routing, for example, up at the top, you could actually run it like that. But the point here is that you don't there's no special configuration that is required, and that traffic shifts to the appropriate physical NIC for IP storage, and it works quite well.